In the standard 7.EE.1, where we are to apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients. A reminder that calculators are not allowed on this standard. You may be presented with a problem like this, where you are to enter the value of n so that the expression 6x plus 8 plus negative 10x plus 1 is equivalent to nx plus 9. So we're trying to figure out what number can replace the letter n to make one part equivalent to another. So how we really should go about trying this problem is by writing down the first expression. From there, anytime we're adding one expression to another and we've got parentheses within the problem like we do here, we could just pretend like the parentheses are not there. And the reason is because typically to get rid of parentheses, we are distributing what's on the outside by everything that's on the inside. So when we have a positive times a negative x, that's still negative 10x. And when we have a positive times a positive 1, that's still positive 1. So in a situation like that, you could just pretend like the parentheses are not there. Now, if there was a subtraction symbol in between those sets of parentheses, that would not be the case. So let's keep going by gathering our like terms. So we have a positive 6x and a negative 10x. That makes negative 4x because we have 4 more negative x's than positive. As far as the constants go, we have a positive 8 and a positive 1. Altogether, that makes 9 positives and 0 negatives, so that would be plus 9. But what we're trying to make is this expression right here, nx plus 9, and I'm simply changing pen colors here. So the question is, what value could we use for n? Well, clearly it would have to be negative 4. With the standard 7.EE.1, where we are to apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients, calculators are not allowed in this standard. We may be presented with a problem like this, where we are asked to enter the value of n. So the expression 1/2 x plus negative 6 plus negative 2x plus negative 6 is equivalent to nx plus negative 12. So basically, we're trying to figure out that if we were to simplify this side, what would the value be in front of the x, the coefficient in front of the x in the answer? So I'm going to start by writing the expression down in the work area here. And then after I do that, I'm going to go ahead and I'm going to simplify this expression. So I'm going to gather my like terms here. So we have a positive 1/2 x and a negative 2x. That ends up being negative 3/2 x. And the reason is because we have, these are x's right here. We have 1/2 minus 2. Well, that's the same thing as 1/2 minus 2 over 1, which is the same thing as 1/2 minus 4 over 2. And all I'm doing there is I'm finding a common denominator by multiplying top and bottom of that by 2. And then we have 1 minus 4 over 2, which is negative 3 over 2. Okay, so that's how we get the negative 3/2 x. And then as far as the constants go, I have a negative 6 and another negative 6 that I'm combining with that. Altogether, that makes 12 negatives and 0 positives. And so if we take this part right here, and I'm just going to try and squeeze it in down below here. and grab my red N, we can see that these two values right here are equivalent to each other. So at that point, if N is -3/2, as we can see right there, then we know that those two expressions are equivalent to each other. Within the standard 7.EE.1, where we are to apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients. Remember, we are not allowed to use calculators in this standard. We may be presented with a problem like this, where we are asked to enter the value of n. So the expression -x plus 6.1 plus -3x plus -2 is equivalent to nx plus 4.1. One way of looking at this particular problem is like this, that if we were to simplify this expression, we are looking for the value that sits in front of the x plus 4.1. In other words, the coefficient. So let's start by writing the problem down in our work area here. Next, we're going to gather our like terms. So let's go ahead and put a 1 in front of that x, because that really is a -1x. And we're going to combine with that 3 negative x's. That makes 4 negative x's. So we have -4x. And technically, we could figure out what n is just from that right there. But I'm going to go ahead and pretend like I didn't notice that. So if I gather my constants together, I have a positive 6.1 and a -2. We have 4.1 more positives than negatives. And so if I take this and write it right here, but I'll grab my red pen for the n, we can see that in this particular problem, n would have to be -4.